Well, welcome back to this discussion about the law of cosines. And now that we kind of have an idea of what the law of cosines really is, it's time to jump in and actually use it. So there are two types of triangles that we are going to use the law of cosines to be able to solve. And we're going to start with an SAS case where you have two sides of the triangle and the angle that is between those two sides. So let's jump in. The first type of triangle is an SAS triangle. This is a triangle where we are given two side lengths and the angle measure that is between the two side lengths. So when we're given this information, we're definitely needing to use the law of cosines, and there are a couple of things that we need to remember. We need to remember that the law of cosines, we're going to start by using the law of cosines to find the side length opposite the given angle measure first. Then once we have that angle measure, we'll have a pair, an angle measure and an opposite side length. So then we can revert to the law of sines to find the measures of the other angles, okay? But we are going to focus first on the smaller of the two remaining angles, and this angle will be acute. It's got to be acute. And then after that, we're going to use the triangle sum theorem to find the remaining angle measure. So here's an example of an oblique triangle where we're given two side lengths and the angle measure that's between them. So now this is in a slide that talks about SAS triangles, but as we are developing these skills, you should be able to take a triangle with some information and then determine what kind of information you're given so you know which tools to use. So you definitely want to know how to do this. This particular triangle gives us two side lengths and the angle measure in between them, so we know that this is an SAS triangle. We want to solve the triangle, which means finding every angle measure and every side length. And it is helpful for us when we are wanting to do that to organize our work by determining what we know and what we need. After we do that, it's easy to kind of use these steps and decide what we need to go to first. So our first step here is use the law of cosines to find the side length opposite the given angle measure. So we know angle B has a measure of 25 degrees, so we want to find the length of side B. Okay, so we know angle B, we want to find the side length B. So we're going to use the law of cosines to find the length of side B. And here we are, we've got B squared is equal to A squared plus C squared minus 2AC times the cosine of angle B. And we're going to go ahead and sub in what we know. A is 66 feet, so we're going to sub in 66 here. C is 100 feet, so we're going to sub in 100 here. And likewise, 66 and 100 here. And angle B is 25 degrees, so we can sub in 25 degrees there. Now we can go ahead and crunch this in our calculator, and we would want to make sure that our calculator is in degree mode. And when we do that, we're going to end up with 2392.74. And so that's going to give us B squared, but of course we are interested in actually the measure of side length B. So we're going to have to take the square root, and we're going to go ahead and round that to the nearest tenth of a foot. So that gives us the first of our three pieces of information we need. Now once we have a pair, we can go ahead and use law of sines for the remaining angles. Now remember that the second step says we want to find the measure of the smaller of the two remaining angles, which will correspond to the shorter of the two side lengths. So we want to look at the measure of angle A. So let's go ahead and set up a law of sines proportion. Sine of 25 degrees over 48.9 will equal the sine of angle A over 66. We will isolate what we're trying to solve for. So first we'll isolate for sine of A by setting it equal to 66 times the sine of 25 degrees over 48.9. And then we really are not interested in the sine of A as much as we are interested in the measure of angle A. So we will need to use a sine inverse to get that measure. So we're going to use our handy dandy calculator, and we should end up with a measure of about 34.76 degrees. And we're going to go ahead and round that to the nearest whole degree. And we see that to be 35 degrees. And then the last angle measure, we'll go ahead and use the triangle sum theorem to find the measure of angle C. So we know that 35 degrees plus 25 degrees plus that measure of angle C will equal 180 degrees. That will give us the measure of angle C to be 120 degrees. And voila, we have solved our triangle.